Division of polynomials, remainder and factor theorems. So we're going to go ahead and go straight to synthetic division. And synthetic division can only be used when your divisor is of the form x plus or minus c. So this cannot be x squared. This cannot have a number in the front. It has to be in this form. And then you can use a synthetic division, which is just a little shortcut to divide without all the variables on, and then you put them back at the end. So to set it up with synthetic division, you make your little grid. It's like a little backwards L. And your divisor is going to have the opposite sign of this. So what you're going to put here is a positive 3. This is in the x minus c form. So it's a positive 3 that goes here. You make sure that your dividend is in descending order and that it's not missing any terms. If you are missing any terms, you have to put 0 in as a placeholder. We are not missing any terms, so we're going to pull the coefficients off. So 1 for x cubed, 4 for x squared, negative 5 for x, and 5 for the constant. Right. You're going to skip a row, draw your line. Your first one comes down below the line, and then it's going to be multiplying and combining. Right? And using the opposite sign here takes care of, if you think about long division, when you multiply back, then you subtract. Using that opposite sign there takes care of that. So you will just add with whatever signs you have. All right, so we're going to multiply. So 1 times 3 is 3, and it will go here. 3 plus 4 is 7. Then you're going to multiply again. 7 times 3, 21. 21 and a minus 5 will give us 16. 16 times 3 is 48. And adding this will give us 53. Now we're going to put it back together. You're going to drop 1 degree lower than what you had. We had x cubed, so we're going back to x squared, and these will be our coefficients. So it will be 1x squared plus 7x plus 16. The last number, if it is not 0, is a remainder. So plus 53, it goes back over your divisor. Right? We are going to use this going forward, and we're going to hope to get a 0 for our remainder. If we do, this piece we're dividing by is a root of this polynomial, and that means that it would cross the x-axis at that point. That's why we're using this synthetic division to find those zeros. Here's another problem to practice with synthetic division. And so our divisor is in the proper form, x plus or minus some constant. So we can do synthetic division. We'll make our grid, and you want the opposite sign here. So we're going to have minus 4 this time, because the form is x minus c. So if it's plus, it's really minus a negative. So that's what we get, minus 4. Take your coefficients from your dividend, and they are in descending order. There are no missing terms. So we have 5, 3, and negative 5. Skip a row, draw your line, bring your first one down. So we're going to multiply 5 times negative 4 is a negative 20, plus 3 is a negative 17. Multiply back. Negative 17 times negative 4 is going to give us a positive 68. And 68 minus 5 will give us a positive 63. So we'll put it back together with our variables. We drop 1 degree lower than where we started. We started at x squared, so we're going to go down to x to the first. This will be 5x. You don't have to write to the first. Minus 17. This one does have a remainder, so it is plus 63 over our divisor, x plus 4. So we have another problem for synthetic division. It's just written in horizontal form. We want the opposite sign, so we actually just want 4 here for our divisor. When you pick your coefficients, you have to watch out on this one because it is missing a term. It's missing the x squared term. So you have 3 for x to the 4th. You have minus 6 for x cubed. You do not have an x squared, so you have to put 0 in that place. You do have an x term, and you have a constant. Right? And then it's going to be the same. So draw your line. First one comes below, and then you multiply. So 3 times 4 is 12. 12 minus 6 is 6. 6 times 4 is 24. 24 plus 0 is still 24. 24 times 4, 96. 96 plus 2 is 98. 98 times 4, this one is kind of big, 392. And 392 minus 8 is 384. Now we'll put it back together. This time we started at x to the 4th, so this is going to be 3x cubed plus 6x squared plus 24x plus 98 plus 384 over our divisor, which is x minus 4. For this problem, we need to switch it around to descending order. And so my highest exponent needs to go first. So I have x to the 4th minus 5x cubed plus 2x squared minus 10x. And notice this one is missing a constant. Right, and we're dividing by, I'm just going to switch the order here, it's x plus 5. So we'll write our little grid, and we're going to use a minus 5 here. Coefficients, we have 1, negative 5, 2, negative 10, and we have to put a 0 in the constant column. Bring the first one down. So 1 times negative 5 is a negative 5. Like signs, add, keep the sign, negative 10. Negative 10 times negative 5 is a positive 50. 50 plus 2 is 52. 52 times negative 5 gives us negative 260. And a negative 10 gives us negative 270 times a negative 5, 1350, positive. And that's going to be your remainder. And I am sorry I got so close to the edge. All right, we're going to go back this way to write it. So we're going 1 degree lower. It was x to the 4th. So this is going to be 1x to the 3rd minus 10x squared plus 52x minus 270 plus 1350 over x plus 5. We're going to do one more problem and try to lead into our remainder theorem with it. Right, I'm going to work over here so that I can do more on this screen. And so we'll set up with synthetic division. We will use a positive 2 here. It is in descending order. We are missing the x squared term. We do have an x term, and we have a constant. So bring your first one down. So 2 times 2 is 4, plus 0 is still 4. 4 times 2 is 8. 8 minus 4 is 4. 4 times 2 is 8, plus 6 is 14. Now we'll put it back together. We're dropping 1 degree lower, so this is 2x squared plus 4x plus 4 plus 14 over x minus 2. The next problem gives us a polynomial, and notice this is the same as your dividend, and it asks us to evaluate f of 2. So a couple ways you can do that. One is you can plug the 2 in. So we can plug the 2 into all our variables, use order of operations, and work it out. So we have to do the exponent before we multiply. So this would be 8 times 2 is 16 minus 8 plus 6. So 16 minus 8 is 8 plus 6 gives us 14. All right. We could also evaluate it on the calculator. So let's put it in. So turn it on, do y equals. Type in your polynomial. So 2x to the third minus 4x plus 6. And we will do, we'll just hit graph. We didn't need the graph, but we'll do second calc. And what we want to know is value, number 1. And we want to know when x equals 2. And click enter, and it gives us the answer. So that's evaluating. So it's second calc value. Now, what I want you to notice here, and this is why I put them both on the same page, because we were using the same dividend, is that when we evaluated the piece we divided by, the answer is this part of the remainder. So evaluating at what you're dividing by gives you the remainder. And so they have given us a problem, and they ask us in the directions, they say use synthetic division and the remainder theorem to find the indicated function value. So they want us to do synthetic division, and we are in descending order. So we have 3, -5, -2, and 5. Our divisor will be -5. We'll skip a row. Bring our first one down. 3 times -5 is -15. Like signs add. -20. Positive 100 minus 2, 98. And 98 times -5. -490. Plus 5 would be -485. So we could write it back. It is 3x squared, because you go 1 degree lower, minus 20x plus 98 plus -485 over x. It's plus 5 here. That's how you get a -5 for your divisor. And what they want to know is what is f of -5, and it should be the remainder here. So it should be negative 485. Now, we could plug in negative 5 into all this problem. I'm going to go straight to the calculator, but you could do it manually. Negative 5 into each x, work it out. It should give you negative 485. And then remember, it's second calc value. And so we want to know when x is negative 5 and y is negative 485, which is our remainder. So that's just a little double check. Now, since they're still just asking us to evaluate this, I'm going to punch it in there to evaluate it, and then I know that's the remainder. Later on, when you're going to solve and you're finding if something's a 0, you would need the rest of the polynomial. But for what they've asked me, I really don't. So I'm going to take a shortcut and just type this in. So x to the 4th plus 5x to the 3rd plus 5x to the 2nd minus 5x minus 6, enter, and we could graph it. All right, and second calc value, and we want to know for 3. Enter, 240. Let's just look for a second at what that means on the graph. So we want to know when x is 3, what is the y on this function? And so when our x is 3, here's 1, 2, 3, it is way up there at 240. For this next one, just so that you will feel comfortable doing synthetic division with a fraction, I'm going to go ahead and do synthetic division. If I was just doing it myself, or if you were just doing it yourself, and all you needed was the remainder, graphing calculator is a good idea. All right. But we'll do synthetic division just to show that we can with a fraction. So we have our grid. We have a half. We have 2, negative 5, negative 1, 3, and 2. A lot of times, if they give you something that where you need a fraction, it will cancel quite a bit. So we have a half times 2. Half times 2 gives us 1. And you can do that on the side. This is 2 over 1. These cancel, gives us 1. Or do it in your calculator or do it in your head, whatever works. Okay. So this gives us negative 4. A half times negative 4 is going to give us negative 2. This will give us negative 3. And this is our first one that's not so nice. Negative 3 times 1/2 is going to give us negative 3/2. This is what we have times 1/2. You're just going to multiply across. Nothing cancels for you. Right, and you might remember that this is negative 1.5. And so 1.5 and 1.5 makes 3. And so if we combine these, we are going to have positive 3/2. Right, and then positive 3/2 times 1/2. Right, nothing cancels for us, so this gives us 3/4, multiplying across, and plus 2. you would want them to all be the same. So a couple of ways you could go. You could do 2 over 1 and get a common denominator of 4. Or you can say that is 2 3/4. And then convert it to an improper fraction. So this will give us 8, 9, 10, 11 over 4. That's not the only way to do that. Right, so f of 1/2 is 11/4. Right, we'll go to the graphing calculator just a minute to verify. And so I have already typed it in. And I'll say enter. And I could say graph. And I'm going to say second calc. I want number 1. And I would just put it in as 0.5. If you want to enter a fraction, use parentheses. So parentheses 1 divided by 2. I'll put it that way. But 0.5 would also be fine. 1 divided by 2. Whoops. 2, close, enter. Right, and it switched it to a decimal, 0.5. And they're giving us the answer as a decimal, 2.75. That is the same as 11/4. On your calculator, you can check that. So we'll remember 2.75. And let's just clear this. And do 2.75. And do math menu. And your first one will put it back to a fraction. And hit enter one more time. And there's your 11/4. And that's also a useful skill, just to be able to switch something back to a fraction. We have one more to do, and I'm going to go ahead and do this one with the synthetic division because it's going to lead us into our next part. And so we will write our grid. We are dividing by 2, so we're really dividing by x minus 2. So we have 1, -5, 2, and 8. Skip a row, bring down. 1 times 2 is 2. This is a -3. -3 times 2 is a -6. This gives us a -4 times 2 is a -8. And we get a 0 for remainder. Going forward, you're going to be real happy about that 0 there. So that's our answer to this piece. And if you did it on the calculator, or if you just plug the 2 in, you would get 0. Now, what that means is that this is an x-intercept of the graph. I'm going to go ahead and get back my polynomial here. So I was at x cubed. Now I have x squared minus minus 3x minus 4, and no remainder, so I don't put that on. Right? 2 is one of my zeros. So one of my places where this is equal to 0. 2 is one of those. What you're going to try to do going forward, once you find a 0 and you can get this polynomial back as a quadratic, you know how to solve quadratic equations. If it's higher, you don't. That's why you have to get it down that low. So your goal is get it down to a quadratic equation. It might factor, it might not. If it doesn't, you can always go to quadratic formula. So let's find the other zeros, or the other x-intercepts. So we're setting this whole thing equal to 0. And so this, I believe, we could factor different signs. And 4 and 1. And we'll put the 4 with the minus. So we're going to get x equals -1 and x equals 4. And you can have as many zeros as your degree. So we could have 3 zeros, and that is what we have. We have 2, we have -1, and we have 4. So I'll pull up that graph. So let's look at a picture of this graph. What these are the x-intercepts, or the zeros. And so here is our -1. Here is our 2. And here is our 4. So we have our zeros. So if you think back just a little bit, we were looking at drawing these functions. And so if we have this function, our degree is 3, so it looks somewhat like a cube, right? Leading coefficient's positive, so we know for our end behavior it's going to look like this. And then if you can get your zeros, that will help. We talked about multiplicity. None of these occur more than one time. So they all occur once. That's an odd multiplicity, so it's going to cross through it those. So you would put those points on. You would know your ends, and it's going up some here and down some here. But that would be your start to draw the graph. So end behavior and then knowing the zeros. So this is getting us ready to find the zeros.